Da-da-da-da, da-da-da-da, da-da-da-da. Da-da-da-da-da. Hey, I'm gonna steal, as a matter of fact, some of these magnets. Don't tell anybody.
Oh.
And I'm gonna give them to my family.
Me too.
Why?
Because they're cool. And because I like my family.
Well, what's fact families, anyways? We're supposed to talk about that today.
Oh.
I don't really know what it is.
Fact families. They're facts and they have a family.
I can't breathe.
I can't breathe.
All right. My goodness.
Okay, so today we are talking about fact families. Talking about division, starting off division. We have been doing multiplication for quite a while. Whew, I'm going to leave mine on. I think I can do it. All right, so a fact family is a group of related facts using the same numbers. So just like we multiplied, now we're going to be dividing. You want to show us how to do it?
Why, certainly.
Okay.
All right, so we've got a visual representation here for you of a triangle. And in the triangle, we've got the symbols multiplication and division, because the cool thing about this is because it's a fact family, you can use both. And we have three numbers. One's going to go in each corner. So for this particular fact family, I'm going to have the numbers 72, 8, and 9.
And you know what happens, sometimes we're not as comfortable with division, and so people will say, oh, I know how to multiply really well because we just finished that in chapter 2, but I don't really know a lot about dividing. But what you have to realize is they're all in the same family.
And we can make 4 different sentences, multiplication or division.
Yep.
Did you call them sentences? What would you call them?
You call them like equations.
Equations, yeah, with just these 3 numbers. So pick any of these 3 numbers, Miss Rutledge, and tell me what order you want them to go in.
Let's just start here because I'm a lefty, so I always think left to right. So
Okay.
8, 9, 72.
8, 9, 72. How can we plug in multiplication or division to make this true? We know that it has to equal 72.
Yep.
So what makes that true?
8 divided by 9 is definitely not 72.
Nope.
So since it's getting bigger, so it's got to be multiplication.
So there's 1. Okay. Now we can just flip. You know what that property is called?
Ooh, where you flip them?
Yep.
The commutative property.
Yep, because you get in your car and you commute places and you flip. So we're going to commute these 2 numbers, and we can just flip-flop them because 8 times 9 is the same thing as 9 times 8, and they will both equal 72. So again, I still use just the 3 numbers that were in there.
Yep, okay. Now we can do a different order. Now we can't do 9, we've got 2 multiplication, and then we'll have 2 division. So we can't do 9 and we got to start with a bigger number. So we're going to have to start with 72 on these ones.
Because division is breaking things and making them smaller.
Yeah.
So we got to start big. So we're going to actually start with our product that we had in the first 2. We're going to start with the product, and then we're going to use division this time.
Exactly.
Okay. So does it matter which one I use?
It doesn't, because we're going to use either one. So you can start with 8.
Okay, so if I've used 8, the only number left is a 9.
Yep.
And then my last fact family, again, starting with 72. This time I'm going to commute the other numbers, 8 and 9 again. I'm going to divide it by 9, and I'm going to get 8. So now we have a fact family of 4.
There we go. Now, sometimes, as I steal a marker, because I'm still a bandit and I like to steal things right now, sometimes they're going to give you a triangle and you can figure it out. Sometimes they're just going to give you numbers like this, and they want to tell you to write the fact family. So sometimes you're going to have to do this, and you'll just have to figure out, okay, in what sequence do these go? Remember that you'll always have 2 that are multiplication, and then you always have 2 that are division. And just like Mrs. Roy said, you're always going to have 4.
Yep.
All right?
All right. Let's move on to
some patterns.
I really like this, and my kiddos last year, once they got the hang of it, were like, this is so cool. I think we've kind of introduced this to you before in some of our previous videos, but now we're going to talk about it just a little bit more. So I'm looking at number 3 of your guided notes, and I kind of like to think of this as a balance beam. So if you take something off one side, you have to take it off of the other side. So let me explain what that means. We're going to start with our basic facts. Easy enough. What is 5 divided by 5?
Ooh, 1.
1. Okay? Now, when I have zeros, I can cross-cancel them only if there's 1 on each side. So the division bar is kind of like the middleman. So I have 2 zeros over here, but no zeros over here. And I told you that you have to have one on each side in order to cross cancel. So what that means is I don't have any over here to cancel these. So since I don't have any, I just have to take those two and add them to the end. Okay? So 500 divided by 5 equals 100. Let's check that with our fact family.
Ooh, okay. Let's see. We can go backwards and we can do 100 times, because the inverse operation of division is multiplication, times 5 equals 500. Oh, that's totally true.
There you go.
We're good to go.
Okay, now I want to show you one where it is going to be able to cross cancel. These couldn't because I didn't have zeros on both sides of that division bar. Look at this one though. We've got 240 divided by 30. Okay, so it's a 1 for 1. Start with your basic fact. What's 24 divided by 3? 6.
Nope, 8.
Ah! Sorry. Gotta learn those math facts. Okay?
You were just thinking of 4.
No, 1 for 1. So what that means is, here's your division bar. Check on this side. How many zeros do I have? 1?
Oh, 1.
Check on this side. How many do I have?
1.
1. So, because I get to do a 1 for 1, I get to cancel them both. And do I have any zeros that are not canceled to add over here?
Nope.
No, I don't. And I truly want you guys to mark through them so you don't forget and add them on to the end.
Now, this
Okay.
is a little different because in multiplication, we would have said, well, now there's 2 zeros. But you got to remember, we're dividing now, and that division sign means we're getting rid of them. So dividing, we're breaking it into groups. If I had, basically this is representing like 10 over here, and I'm getting rid of them.
Yep. And let me show you what that would look like if it was multiplication really quickly. So just as a review, we would have done the basic fact of 24 times 3. I can't really do that in my head.
Yeah, I don't know my 24s.
Not really. Okay, so that would be 72. And then in multiplication, numbers get bigger. So we would have added on these 2 zeros. Okay, that's totally different than what we just got because we have a division sign and a multiplication sign. Over here, we did 24 divided by 3 to get 8, and I had a 1 for 1 across cancel.
And Mrs. Roy, that makes a great point because you need to remember that your numbers are always getting smaller in division and bigger in multiplication. So if I start off with 240 and I'm dividing it into 30 groups, kind of think about that in your head. Okay, there's 240 kids, let's say in 5th grade, and I'm putting them in 30 teachers' rooms. Well, that's going to be pretty small classes. I wish we had classes that small. That'd be great. But if I had 240 and I'm like multiplying them and getting 30 kids to every group, that's a lot more.
Yeah.
So always think about that too.
Okay, all right.
All right, now we're going to hit some estimating. So later in this chapter, we're going to be dividing, so get ready, it is coming. You cannot avoid it. But for right now, we're just going to look at estimating. So we've got this problem, 635 divided by 8. In multiplying chapter 2, we did talk about compatible numbers. Now the difference with this and when you're dividing is that you always, when you're estimating, want to get something that doesn't have a remainder. So you don't want to mess with the remainder. So let's see, well, I've got 635 divided by 8. I don't know what that is off the top of my head. Mrs. Roy, do you know what that is off the top of your head?
I do not, sadly.
Okay, so I'm going to start and try to change this number to something that I know can divide by 8. Some of you might say, oh, well, 600, that's a good compatible number, and it is. But can I do 60 divided by 8 really nice and evenly? I can't. So what I like to do is think, okay, what are my multiples of 8? What would be something that would go really easy? And then
Let's just start. 8 times 5.
Oh, 8 times 5 is 40.
Okay, here's what I'm looking at. Maybe you're going the same direction. I'm looking right here. Trying to get a number close to that. So 8 times 6.
8 times 6 is 48.
Maybe we can get closer. 8 times 7.
56. That's
8.
pretty close.
It is pretty close. 8 times 8.
That's 64, and if I was to round, that would be closer than 56.
So I think you should go with 64.
So I'm going to go with 64 because I know it's a multiple of 8. And now because I had to round this one, that one becomes a 0. So my new problem would be 640 divided by 8. And then that's really nice and easy. Just like Mrs. Roy just showed us, I just look at those front ones and I say, well, 64 divided by 8 is 8. And then I've got a 0, so I put my 0 here. So again, we can think of compatible numbers, but you really want to be thinking of what can I divide and not have a remainder. So let's do one more.
I remember telling my kids last year, you basically cover up the last digit, and you're only looking at those front two to get your number. And then this guy, the last guy you were covering up, becomes a 0.
That's a good idea.
So that's a good trick, if that would help you. Let's see if it works on the next one, too.
Okay, what's my next problem?
850 divided by 9.
850 divided by 9. Okay, so she said to cover up this first one, which is a 0.
It is a
so
0.
Really, I'm just looking at this. Okay, so I've got 85. Well, if I think of my 9s.
9 times 6, that's pretty far. 54.
Yeah.
9 times 8.
72.
9 times 9?
Ooh, 81.
9 times 10?
That's 90.
Which one's closer, 90 or 81?
Well, 81 is because it's only 4 away versus the 90, which is 5 away. It's really close, though.
Yep.
So I'm going to go with 81 and actually round it down, which seems a little weird. You could have rounded it up either way, but this one's closer to 81 than it is to 90. So then I just leave my 9 the same. Sometimes you could round it, but overall we're going to just focus on our dividend number. All right, so then I've got my 81 divided by 9, which is 9. And I've got a 0 that won't cancel with anything, so I've got to add it. And again, do you want to check for me, Mrs. Roy, make sure it works?
So Fact Family says that I can work the opposite direction, and I can do the opposite operation, or the inverse operation. So I'm going to go 90 times, that's the opposite, 9, 90 times 9. And I can't technically do that in my head, but I do know that I can go 9 times 9 is that 81, and then in multiplication you add on zeros, so I can add on that 0.
Awesome.
And you got it.
All right. Anything else we need to add on today?
I don't think so. I think we're good. Good luck, guys.